Right, we're carrying on with this magnetism sheet. Right, so the second question is about magnets. Which of these substances is not attracted to... I know copper isn't, so it's non-magnetic. So you have materials which are magnetic. So for example, steel, iron, nickel, cobalt. You have non-magnetic materials. You have non-magnetic materials such as rubber, wood, plastic, and in this case, copper. So all metals are not magnetic materials. Right. Diagram 1 shows a bar magnet. Draw magnetic field lines on them. Right. Just remember, magnetic field lines always travel from north to south. So you put an arrowhead there. What we'll do is we'll do that. Right. Then you go that way. And then you go that way. And that's it. You can do more, but that's it. They shouldn't be touching. And I could do another one, just leave it like that. That's what they're saying in the mark scheme. That's fine. Keep it simple. Right, some bar magnets are made of steel. Explain why steel is a good material for making bar magnets. So, steel is a magnetic material. So the steel magnet will stay magnetized for a long period. Right, 1, 2. Right, so because it's a good material, so let's try to do something here and learn this word. Because it's a good material for making magnets, it's called a hard, can I spell hard? Hard magnetic material. Material. So it's a hard magnetic material. Right. That's it. Done. Right. Diagram 2 shows a cross section through a wire placed between magnetic poles. The direction of current in the wire is out of the page, so it's coming up towards us. Yep. Right. So we need to use, no, what they're saying. The direction of the current is out of the page. Okay. Draw an arrow to show the direction of the force on the right. Let's get rid of that. I just did the direction of the current. Right. So draw an arrow on diagram to show the direction of the force on the wire due to the magnetic field. Assume that the magnetic field is right. So it's gonna be in that direction. Right. It's a okay. So there's two things that they want from here. The line. So that line there has got to be horizontal. Right, and it's got to be pointing to the left. That's where your 2 marks are coming in. Right, how does that work? So what we've got to do is, let me get Fleming's left-hand rule. Right, okay, let's have a look at this. That's your Fleming's left-hand rule. Right. So you've got your thumb, you've got your and you've got your. So this is how they've said. That's your thumb. Right. This is your first finger. And this is your second finger. Right. The M in thumb. Now someone's described this as, which is fair enough, right? Mother, father, child. I like that description. Right. Now we've got to figure out the M is. Oh, right. 1 second. Right. Back again. Right. The M there is the motion. This is the movement. The F is the which way is the field going, and the C is which way is the current going. So what they've said is, and these are all at right angles to each other, yeah? So can you see this here? They're at right angles. Yeah, at right angles to each other, perpendicular. So let's go back. They've said, so we know that the field always goes from north to south. Okay, we know that. Right. We know here, they've said the current is coming out of the page, so just pretend it's coming up towards us. And what we do is we do mother, first finger is father, which is the field, and third finger is the child, which is the current. So what you do is the second finger points up. So this is your second finger pointing up. Your field is going up that way, so your first finger goes in that direction, and then your thumb will be pointing in that direction. Now that's horrible the way that works. It's gonna go, yeah. How do I do this now? This is important to see this. If you can see this, it'll be even better. So let's have a look. See if I can do something with that. So what I'm going to do is it no, there isn't. Okay, shall I take a picture? So just bear with me, see if I can take a picture. Right, let's have a look at this. Hello. Right, so if you look here, the field lines are going that way, so that's my first finger, it's going up. Can you see this second finger? It's coming out of the page, it's coming up towards us. So, and because I'm using my left hand rule and they're perpendicular and the thumb is pointing to the left, so the first finger follows the field lines. Can you see these lines here? The first finger, so the second finger is the current is coming out of the page, that's what they said. So then the thumb must be going to the left and horizontally. So it can't be going at an angle. So right, I'm going to leave it like that. So that's Fleming's left hand rule. It's good to know that it's there. Right. All I've done is can I rotate it? I've rotated it. Yeah, there you go. There you go. So that's how they've shown it in the book, and this is how I took the picture. So if I take it back where it was to match with that, right? Okay, it's good to know that, right? So the answer would be, I know it's a bit long-winded, sorry about that, but it's important. If you can, once you've mastered this, these questions are so easy. He says, I totally forgot. Right, state 2 changes that would increase the magnitude of the force on the wire. Right, okay. Right. That would decrease, that would, or not increase, sorry, look. I always assume increase, but it says decrease. So what you do is make the magnetic field weaker. By, oh well, okay, you can also move the magnetic fields, move the magnets, move the magnets further apart. So that means that it's a weaker field further apart. Yeah, you can use weaker magnets. So any of these use weaker magnets. If you have a weaker magnet, you have a weaker magnetic field. So they'll allow any of this. You can yeah, okay, you can use a smaller current that will generate a smaller magnetic field. Okay, you can use a smaller voltage. So any of these will have that effect. That's what they're trying to say to you. So what I tend to do is use a weaker magnetic field or magnet, and use a smaller current. Those are the two I think that I've got in my head. Right, do you know what I'm going to do is I'm going to call it quits at that there. We'll put this on the next video. Jazakallah khair.